How do I create graph? Graph star G equals malloc size of graph. So with this we create graph. Immediately I'll write return G so that I don't forget it. Next we have to do, we have to initialize its members. Number of vertices, NV equals NV. Number of edges, second member. Initially we put 0. Third thing is our list. So first we want to allocate array. This is array. No. First we want to allocate space for an array which will hold NV members. So if we are saying for 6 nodes create this array. No, right now we are not going to linked list. The first thing that we need is the array. What we are allocating is only for this array. Linked list we are not worrying about. We want to create array of size NV and we want to allocate for that. And each node will store a pointer to head of linked list. So malloc size of linked list node star, and how many linked list node star we want to store? NV. So this is clear. We are allocating an array of this size and each element has size linked list node star. This is clear. So function complete.
We need to create the linked list node.
Right now if we create this array, each element is storing head of the linked list. What is the value initially it will get? A garbage. It will not be null. We just allocated some space on heap and that memory is given to us. You can use this as an array. But right now there is a garbage in it. So initializing that is also a responsibility. So each linked list we have to initialize with null, head of each linked list. So how do I do that? For I0, NV, I plus plus. G of, here this is the thing that we have to remember. Yesterday we were using array directly. Once we move it to graph, we have to use G dash. So all the linked list operation that we will do, G hyphen adjacency list of that vertex. Adjacency list of I. So with this we have allocated space for an array and each member we have initialized with null. That is completion of create graph. Now we come to destroy graph immediately. Okay, you can fix your create graph if you missed anything. Then we'll move forward. So how many of you got it right? Shikhar did that.
So last line, why we kept null, we need to create linked list node na sir there.
For now, we have not inserted any edge.
But we know there are vertices 0 to NV.
Correct.
So we can directly create the
So when vertices are there is no linked list. Linked list represents their connections.
edges.
Right now there is no connection. So when we create graph, there are vertices, that's why we allocated array of that size.
Yes, sir.
But because there are no links, their lists are null.
We could have done create linked list also.
Create linked list node.
In
of
create
I.
linked list, what we do, we pass a data.
Okay.
You remember create linked list we used to pass.
No. Create linked list node at that in that array.
Yeah. Create linked
We
list
create
node
only
function.
one node, na, sir.
Correct. So let's take a look at our create linked list node function. It needs data from you.
I
We cannot pass.
We are not saying 0 is connected to 0.
no, sir. We have created an array, na, sir.
Right.
In that array, in the first element, we'll store 0. We'll store the vertices. Whatever vertices are there, we'll store
can give different
1,
names.
1, 1, like that, sir.
No, here this is just a pointer. 0 is index.
Yes, sir.
So when we want to see for 0, we know we have to go to 0th index of the array, and that will give us the linked list of that vertex. If you say insert 0, that will insert a node in this linked list with 0. That will say 0 is connected to 0. Not clear yet?
Yes, sir. Index we are using as vertex.
So linked list we will make when we are inserting edges. That is only representing edges. Graph, size of graph is size of array. Size of graph means how many vertices are there in the graph. So till graph creation things are clear. Now at the time of freeing we have to make sure our free should be equal to number of mallocs we have done. So we have done 2 mallocs, one for adjacency list, one for graph. So when we are coming to destroy graph, we will free G and we will free G of adjacency list, correct? And then we will return null, right?
Adjacency list should be freed first and then.
Even the nodes we should delete, but is this code right?
Adjacency list should be deleted first, so before the
All
graph is
should
Yes.
be.
She has pointed out error. Can someone else find the error? This code is not right.
We are freeing first G and then access.
We are freeing G and then using G, which is the wrong thing. So what we should do? Great. So we should free adjacency list first. The member should be freed first and then G should be freed. Right? Now, because adjacency list has multiple linked lists, after we insert the edges, then we have to delete all the linked lists also. Because we did not call malloc, we will not free. We will call linked list function to free that. So each linked list we want to destroy. For I0, I less than NV, I plus plus,
Destroy linked list.
destroy linked list nodes. What is the head we pass to that? What was signature of destroy? Hmm? G of NV. Good point, yeah. Now it should be G of NV, not NV. Destroy linked list nodes. What is the head? G of adjacency list of I. That is the head for that vertex. That's the only parameter we give. And what this returns to us? It returns null. Though this is not needed, but we can still assign null to it. That means we are freeing everything and we are assigning null to it. So we have to make sure all the things that we are using, they get freed when we exit. Now even with this my code will not compile.
In time.
Int I.
In the previous function.
In previous function also we missed int I. So here also we had written a loop, I was missing. Any other thing missing which will stop us from compiling? We are using null. stdlib is there. We called malloc, stdlib is there. I is declared in second function. So this completes creation and destroying of graph.